In this exercise, I want to introduce you to the first of the Excel-based exercises we're going to be doing in this unit. While the demonstrations are all done using the Excel models, I would strongly recommend to you to check the maths as you go using a financial calculator or perhaps a scientific calculator if you only have that available. Okay, to begin with, I'd like you to open up the Introductory Property Maths spreadsheet. This is a spreadsheet which demonstrates basic financial mathematics with a bit of an application to property, and also introduces you the way that the self-correcting functionality works in these Excel spreadsheets if you haven't encountered them before. Okay, the Excel spreadsheet begins with the introductory page. I would recommend that you take time to read this rather than just skip over it. It doesn't take long. It basically gives you a revision of what's going to be covered and what's going to be practiced in the exercise. So it's a good roadmap, an index if you like, for what we're going to be doing. Take a little bit of time now to download and open this spreadsheet if you haven't done it before, because you will find it very useful to be able to press the buttons as I press them in the exercise in this video, and that way you can see that it actually does work. Okay, so read through the introduction. Let's move to the financial functions diagram. I recommend very strongly that you spend a bit of time when you're setting out financial modelling, almost of any sort, whether it's a simple investment acquisition property or some complicated development project or a lease to buy, public-private partnership, whatever you model up using this. And you do use this tool, this basic approach for everything in advanced property valuation, advanced property analysis. I recommend that you use a diagram something like this one. Okay, the layout is fairly simple. It's a horizontal line which represents time, starting at time naught. You'll remember from business finance that the standard convention with annuity calculations is that the cash flows occur at the end of each time period. And so at the beginning of the project, we're at the end of time 0, and we're assuming that in 12 months' time, one period, we're going to receive, in this case, a cash flow of $100. We represent the cash flowing into our pockets as an up arrow, and the cash flowing out of our pockets as a down arrow. And the idea is that over time, the up arrows are meant to balance with the down arrows, and that's the way that financial mathematics in general works, and especially this application. As you open up the spreadsheet, you'll notice the discount rate is set to 15%. If these expressions are unfamiliar to you because you've had a really good holiday since you did business finance, it might be a good idea to go back, have a look over your notes from business finance or the textbook, and reacquaint yourself with these terms. Here we're setting 15% as the discount rate. You'll notice that there are different colours here, and I do that not simply to be aesthetic and cute, but because there is a convention that you will find that I use in all of the spreadsheets that I use. It comes from my experience in industry where we used to build models, and we would always use blue font for data, black font for the answers to calculations, or maybe simply statements and descriptions. And so I'm continuing that convention. Here I'm using a couple of other colours simply to highlight numbers to set them apart a little bit. That's not so important. As long as you remember blue equals data, you will find working with the spreadsheets in this unit a lot simpler. Here we're starting with a discount rate of 15%. This diagram is dynamic. In other words, if you change the blue numbers, all of the black numbers will change, or at least those ones that are affected by the particular blue number you're changing. I'm going to demonstrate that by changing the discount rate to 10%. Okay, and so in this model, I have a property which is acquired, and we'll say for $1,000, that's its present value, its net present value. And it's going to return to us $100 at the end of year 1, $100 at the end of year 2, $100 at the end of year 3, and so on up through 6, 7, 8, 9, 10. And at the end of year 10, not only do we earn the $100 of cash flow, that would be the rent on a piece of real estate, perhaps a dog kennel or something, but we also sell it, a notional sale at least, which is a big up arrow, not necessarily proportional. And when you draw these things, by the way, just get a piece of paper, pull out a pen or a pencil, up arrows, down arrows, put some numbers on, and it just helps you conceptualize what's going on. Here is really simple because it's $100 each year. However, in the very least, in a property investment, the rent will be going up year by year by year with inflation or changes in the property market or whatever. And so those up arrows will be growing or what have you. And it's good to put it down physically on a piece of paper and actually draw it with a pen or a pencil. It helps you to conceptualize it, actually get it into your brain better. So I do recommend that. Okay, and when we sell this little investment property for $1,000, I'm using $1,000, it could be $1 million, doesn't matter, just to give us an idea of the way the numbers work. By using $100 as the cash flow and $1,000 as the terminal sale, it just keeps the numbers manageable for the purpose of the exercise, that's all. Any numbers can go in here. We can change that number if we want. I'm not going to at the moment. Okay, we notice that with a discount rate of 10% and these $100 revenues coming in for a purchase of $1,000 and an eventual notional sale of $1,000, the whole thing balances up. And so if I pay $1,000 for this asset, then it will achieve my investment objectives of returning 10%. That goes back to business finance. Might be time for you to go back and revise your notes on that so you're absolutely crystal clear on what we're doing here. Property investment, property analysis is nothing but a particular specialized application of standard financial theory. Okay, and here hopefully we'll drill you a bit more in and get you really, really sharp with it as the term progresses. What else can we do with this diagram? Well, I said it's dynamic. Okay, currently we're assuming we've bought this property on the assumption that we're going to be getting this series of cash flows, $100 per year at the end of each year, and a sale $1,000 off in the future somewhere. What happens, however, if the alternative investment is actually higher? Let's go back to the 15% we started with. And we can see now that the returns that we're going to get in the future aren't actually reflected in the same value in a present value sense. In fact, now the present value is only $749. And so if you bought it assuming a discount rate of 10%, but your real discount rate was 15% for whatever reason, you have bought a lemon. You will not be performing as well as an alternative investment. This investment won't be performing as well as an alternative investment. How did that magic work? Well, here I want us to go through as a revision and look at the individual components. We'll start off with the cash flow at the end of year 1, $100. There's $100 that comes in at the end of year 1. I have to wait for wait for a year for that to come to me. And because I'm operating at a discount rate of 15%, I have to discount that future $100 back to the present. And I do that by dividing it by 1 plus I to the n. You'll remember 1 plus I to the n is the mantra from business finance, that factor that turns present values into future values and vice versa, depending on whether you multiply or divide. Here we're dividing by 1 plus I to the n. 1 plus I is 1.15%. You can check that maths if you like. And N is 1 for 1 year, period of 1. And we're going to divide it. And so the reciprocal of 1.15 is 0.86. We multiply the $100 we have to wait for by the 0.8696 of discount factor. And that means that the $100 in the future is only worth the equivalent of $86.96 today. Similarly, the rent that we have to pay, the wait 2 years to get, the end of second year, while it comes in as $100, is only worth $75 today. The rent at the end of year 3 is $100, but it's only worth $65 today, and so on for the rest of the period, up until a point where you get to year 10, and the $100 worth of rent is only worth $24 today. In other words, about a quarter of its face value, at least in the way that we look at the face value of a $100 note today. It now becomes a $25 note in 10 years' time. Added to that, the present value of $1,000, which is also about a quarter of its value, or $247.18. And these green numbers represent the present values that when you sum them, they come to the $749, which tells you that the investment is a dog. It's not going to do very much good for you if you could simply go down the street, buy shares in PHP or some other alternative investment that's going to return you 15%. If, on the other hand, the Australian economy is collapsing and the Federal Reserve Bank is chasing around trying to reduce the interest rates to keep the economy afloat, and they take the discount rate or the whole capital asset pricing model structure down a few clicks, and so the alternative investment is not returning 15% now, but only 8%. And we find that all of this mathematical magic now produces a PV, a net present value, the sum here, of 1,134. So if I bought the property for $1,000, it means that I'm actually $134 better off than alternative investments if the best investment can earn 8%. Now, think about in financial ups and downs over recent times. The COVID fiasco of around 2019 and following is still with us, and we still might remember how much the economy was shaken around by that particular phenomenon. And so what was previously higher interest rates and higher expectations of return sort of fell. Before that, now this is getting into the history books, global financial crisis of 2005, 6, 7, 8, around that period. Likewise, we had discount rates, rates of return, interest rates taking a bit of a tumble. So these things do change. And in the future, certainly through your professional lives, you're going to see these ups and downs coming along for good reasons and bad, whatever they are, but they will happen. Okay, so being able to convert your property investment into a model like this, even if it's complex, you might have a refurb in year 5. So the 100 years of rent, $100 of rent is going to be swamped by maybe minus 500 in costs. So you're going to have a down arrow here as well or something. That makes this pattern more complex. It's the sort of thing that you would be doing if you were doing complex property management, facilities management, likewise in more complex development projects. You might be calculating this not on an annual basis, but on a monthly basis, and the up arrows and down arrows would be all over the place, which makes it an advantage to actually draw it out like this. It helps you to visualize what's going on. This is the simplest model. Okay, now a couple of purposes for giving you this model. One is that it is a revision, and hopefully it'll shake away a few of the cobwebs as to what discount rate means, how these intermediate cash flows, the payments change, what the future value thing is. Here in property, it will be a sale, either a notional sale or a real sale, and the net present value usually is the sensible value, the sensible bid to pay for this property at the beginning, if all is known and sensible, which in the property world seldom happens. Okay, the other purpose of this page is to also introduce you to the built-in Excel functions. And so I'd like you to pay attention to these. I have these drawn up so they are fairly dynamic. Here you'll notice that the PV is in terms of an interest rate of 8% because we have 8% up there, and it comes through and it gives you the answer, the NPV, which also happens to be what happens in this cell as a result of summing these things which have been calculated out, if you like, longhand or relatively longhand. But using the Excel, built-in Excel function is a lot faster. So I do recommend that you master how to use these. Now's your chance. And these are the examples of functions that are particularly relevant to this course. And so I do recommend that you practice them, perhaps using this diagram to just bone up on how to use these advanced functions. We will be using them a lot, and so now is your chance to at least introduce yourself to them. Likewise, they are dynamic, so if you change the payment, for instance, to $200, you'll notice that all the numbers on the page change. Okay, play with this, write out a diagram on hand, check it with your financial calculator or your scientific calculator if you don't have a financial calculator, and get very, very familiar with what's going on here, because this needs to be really fundamental. It's like riding a bike. It's hard when you first get it. Spend the time though, learn it, practice it, play with it, and then we'll go off into the future. I think that's about enough for this exercise. The other exercises are applications of these things in different ways. There are these 4 exercises, and then we give you the worked examples. These are only static worked examples. They only give you the answers, if you like, not the equations. It's up to you to go through and knock out the yellow highlights, but that's for a different exercise.